Okay, so hello everyone. In this video, we'll be solving the question number 3014, which is the minimum number of pushes to form a word, part 1. It is marked easy. The question is also very easy to understand. The constraints are also very well within our favor. Once we understand the question, we'll move to understanding examples, where we will see one or two examples and then we will find the pattern. Once we find the pattern, we will put it in the coding language. Okay. So let's first understand the question and then move to the examples. Okay. So yeah, what does the question want to say is that we are given a string word containing a distinct lowercase English words. Telephone keypads have keys mapped with distinct collection of lowercase. Here you can see that each key is mapped with distinct collection of lowercase. Here if you find n, you can check in all other keys that n except of this key and except of this key would not be found in any other key. Okay, so that is what that have keys mapped with distinct collection of lowercase, which can be used to form words by pushing them. For example, key 2 is mapped with ABC. We need to push the key one time to type A and two time to type B. Okay, here 2 is mapped with AFG. If I want to type A, I need to push this key one time. If I want to type F, I need to push this key two times. And if I want to type G, I'll need to push this key three times. Okay. It is allowed to remap the keys number 2 to 9. We can remap from 2 to 9 only, and we need to remap the keys to distinct collection of letters. Like here, no two keys can have same collection of letters, and each character is mapped to only one key. The keys can be remapped to any amount of letters. Here 9 has four characters, but 4 has only 3. So we can map any key to any number of letters, but each letter must be mapped to exactly one key. That is, any character you pick, it is present in only one key only. And we need to return minimum number of pushes to type a word after remapping the keys. Okay. And one asterisk hashtag 0 do not map to any keys. Okay. So asterisk 0 hashtag and 1 do not have any keys characters. Okay. So let's first understand one example. Suppose we have x, y, z, p, q, r. Suppose this is our word. Now we need to remap this entire keypad, but we cannot assign any keys to 1, asterisk, 0 and hashtag. We have only 8 options, which is from 2 to 0. X, Y, Z, P, Q, R. Okay. I'll give X over here. I'll give Y over here. Z over here. P. I can give Q here and I'll give R here as well. I am allowed to give any key, any number of elements. Here 2 has only one element, 5 has 3. Okay, but we just need to make sure that one character is mapped to only one key. And now let's calculate the amount of pushes required. Here to get 1 we need 1. 1 will Y will require 1, Q will require 2 and R will require 3. Similarly, B will require 1 push and Z will require 1 push. So our total would be 1 plus 1 plus 1, 4 times 1 and then 5, which is 9, which is so big because we have another options still open, which is 4, 3, 6, 8. So why don't we just fill each 8 options first and then try to get the used ones once again. So instead of giving QR over here, let's use one of these empty space, which is give Q to 3 and give R to 4. So now let's check 1, 1, 1, 1, 1 and 1. So the QR which were assigned with along with Y, it required 2 and 3 pushes respectively. Now they need only 1 and 1. So what we did is we just use the empty spaces first. Suppose we had R A B. We had two more characters. What I would do is use this empty space which is here. So they would also take only 1 and 1 push. So our one first is that first conclusion, use empty spaces. And how many empty spaces we have? We have 8 possible empty spaces. Okay. Now suppose I have one few more characters like S T U L M. Okay. Now what we do? Now all the empty spaces are filled. So what I will do is I will start filling the occupied here S. So I should put T over here or the next one. I should put T over next one here because if I put T over here, this T will require 3 empty spaces. And if I put that T over here, it will require 2 pushes. So here it will require 3 and it will require 2. And we need to minimize it. So I'll put this T over here. Now U also will be used so that minimum pushes are taken like that L, like that M, and then N. Okay, so our first intuition will be to first use all the empty space and then fill in the same manner. Like to put it in the mathematical terms, it will be like okay, first fill 8 spaces by giving them one character. What we did was for first 8 we give each of them one character, and then for the second 5 we give each of them one. Later what we did is fill same 8 in same manner by giving them one more character. So after each 8 keys have one character, what we do is we try to get that situation that each 8 keys have two characters. After that, each 8 keys will have three characters. So if one key has one, other has two, other has three, so it will result in more pushes. So what we will do is one, 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 1, 2, 3, 4, 5, 1, 3, 4, 5, 6, 1. Now all eight have one character, so we'll add one character over here, and instead of pushing one over here, we will give it to this one. So one push and second push. If it was here, it will be 1, 2 and third push. Okay. So let's just understand it with an example. So as per us, uh, the first eight, which is 1, 2, 3, 4, 5, 6, 7, 8, we will give them, it will require one push. 1, 2, 3, 4, 5, 6, 7, 4, 5, 6, 8. This will require two push. 1, 2, 3, 4, 5, 6, 7, 8. This will require three push, and this will require four push. You are like, so what if it is not this in sorted manner? But it doesn't matter. The first eight characters, first eight will require one push. Okay. Second eight will require one push. Third eight will require three push. Here it will not be one. Second eight will require two push. And the remaining, which is in this case maximum possible, 2, because it is given in the constraint that there are maximum 26 and all are distinct. So remaining will have 4. Okay. So now what we will do is, first 8 will require one push, second 8 will require two push each, and third will require 3, and remaining will require 4. So we will see how many will require 1, and after all 8 are filled, then we will see how many require 2 push. After these 16 are filled, we will see how many require 3. This is how many are in first 8, how many are in second 8, how many are in third 8. So instead of doing that, what I'll try to do is get the number of groups, which will be nothing but length divided by 8. Okay. If there are three groups, first group will require 8, another will require 16, another will require 24. If there were two groups, it will require 8 and it will require 16. If it was one group, it will require 8. If it was 0, it will require 0. So you can see that, which is nothing but 8 into 1, 8 into 2, 8 multiplied by 1 plus 2 plus 3 equals to 8, 1 plus 2. So this is 1 plus nothing, 1 plus 2, 1 plus 2, and 1 plus 2 plus 3. So we can get it by 8 star n star n plus 1 by 2, which will become 4. Okay. And for the remaining, if there were three groups, remaining will require 4 multiplied by this. If there are three groups, the remaining will require 3 pushes, 3 and multiply by n. If there was one group, the remaining would require 2 pushes. Okay. So the remaining would be N is the number of groups here. So the remaining will require RAM multiplied by n plus 1. If there were n group, if there was n group, it would require n plus 1. If there were two group, it would require 3 pushes. Okay, and RAM is len modulo 8. Okay, so let's just implement it. Okay, so what we'll do is get the length int len equals to what dot size what dot length number of groups, so nothing but len divided by 8 ram equals to len modulo 8. This is a counter and plus equals to 4 star length multiplied by not length but number of groups plus 1. I guess there is one extra. Okay, and plus equals to ram star number of group plus 1. Okay. So what will the time complexity? These are all just mathematical equations, so it will be constant space. Just this word length may require time. Okay, so I hope you guys enjoyed this video and understood what was the approach, how we solve it, how we filled the first 8 and then move to filling or adding one element to each key and then filling those all 8 with 2 characters and then moving to the third character filling. So yep, if you have any doubt, do let me know.